Welcome to the boardroom. Today, our core objective is to engineer a mathematical response that absolutely guarantees a top band valuation in the Cambridge AS and A-Level Mathematics 9709 syllabus. Specifically, we are diving deep into the portfolio of series, geometric progressions, convergence, and sum to infinity. I need you to completely shift your mindset right now. Stop thinking of your upcoming exam as just a standardized test. Instead, you need to view it as a rigorous, high-stakes corporate proposal submitted to a panel of extremely strict auditors, the Cambridge examiners. Let me be clear. Every single mark on that grading grid is highly guarded capital, and right now, incredible amounts of your academic equity are being left on the table. Why? Because candidates simply do not know how to structurally present their mathematics. They walk into the boardroom with sloppy data, and their valuation plummets. Well, we are going to change that today. I'm going to guide you through a strategic C-suite level briefing. We are going to ensure your data structures are absolutely bulletproof, your analytics are razor sharp, and your evaluative reasoning is operating at an elite executive level.
We have intercepted some direct intelligence from a senior examiner, and I want you to treat this quote as a critical internal memo. They recently stated, most students lose easy marks on series, geometric progressions, convergence, sum to infinity, but after this explainer, you won't be one of them. We need to pause and analyze this like a quarterly earnings report. Why are candidates losing what the examiners literally call easy marks? It is definitely not because they don't understand basic multiplication or division. It is a systematic failure to adhere to the strict analytical frameworks demanded by the marking scheme. You see, the examiners are conducting a relentless compliance audit of your paper. If you jump straight to a final answer without documenting the systemic flow of your geometric progression, your proposal's value crashes. This explainer is your exclusive, behind-the-scenes look into that marking grid. We are going to decode exactly what these auditors are looking for so you can lock in those assets and guarantee your success. To secure that top band grade, we need a flawless roadmap. Here is the structural blueprint for today's briefing. Phase 1, the conceptual framework. Phase 2, the procedural sequence. Phase 3, critical analysis skills. And finally, Phase 4, top examiner warnings.
Let's initiate Phase 1, the conceptual framework. Ultimately, what Cambridge demands before anything else is a connected, conceptual understanding. This isn't just about knowing a formula. It's the mastery of fundamental principles that can be logically and structurally transferred to completely unfamiliar contexts. To truly grasp what this means, I want you to imagine two radically different junior associates pitching a response. We'll call the first associate Alex. Alex is a raw data miner. Alex memorizes every single formula in the textbook and provides massive volumes of facts. But if a sequence is diverging, Alex will blindly plug numbers into a sum to infinity formula without ever checking the mathematical conditions. That is a structural failure. Then we have our second associate, Sam. Sam is the intuitive guesser. Sam speaks fast, pitches brilliant creative concepts, and can look at a sequence and correctly guess exactly where the trend is heading. But Sam lacks hard asset backing. Sam refuses to write down formal algebraic steps or explicitly define the common ratio. Let me tell you right now, Cambridge rejects both of these proposals instantly. The examiners aren't looking for a mindless human calculator, and they aren't looking for a creative guesser. They want to see that you understand the underlying why of a geometric progression. Think about the common ratio, R. If R represents a growth rate, what actually happens when the absolute value of R is less than 1? The series converges. It stabilizes. Understanding that intrinsic property allows you to seamlessly adapt when Cambridge throws a completely unfamiliar, highly complex contextual word problem at your desk. You don't panic, because your fundamental principles are connected, secure, and conceptually sound. The absolute crucial point here is understanding the stark difference between high-value analytical depth and low-value superficial breadth. Imagine you are faced with a high-tariff, multi-part Cambridge question. The specific command word is evaluate the sum to infinity. A candidate relying on superficial breadth, like our associate Alex, will just frantically write down the formula S equals A over 1 minus R and slap down a final raw number. That is a low-value descriptive text block. The moment the examiner sees that unstructured pitch, your marks are heavily penalized. Why? Because you completely miss the explicit constraints of the command word. You failed to prove to the board that the series can even be summed to infinity in the first place. An answer that demonstrates true executive analytical depth starts by explicitly extracting the first term A. It calculates the common ratio R with clear working. And critically, it explicitly states that the magnitude of R is less than 1. You have to put that in writing. That one little inequality actually justifies your use of the convergence formula. Missing that single keyword constraint is a regulatory breach that triggers an immediate and devastating valuation drop on the marking grid.
Let's move straight into Phase 2, the procedural sequence.
In this boardroom, we have incredibly strict presentation conventions to follow. proper headings, correct terminology, appropriate formats, and clear annotation. Let's think back to our two failing associates. If they were to collaborate, Alex might try to overload the opening of their answer with verbose dictionary definitions of geometric progressions, just to prove they memorized the textbook. Sam, conversely, would fight to rush straight to the limit calculation without defining a single variable. They both fail the compliance audit right there. The massive data dump violates the appropriate format mandate because it wastes precious exam time on zero-yield information. The rushed calculation violates the clear annotation mandate because it completely skips the structural setup. If you fail to adhere to these presentation compliance standards, it results in an immediate loss of marks, period. It literally does not matter how brilliant your actual math skills are. You must document your mathematical process with the absolute precision of a financial auditor. So how do we fix this? Here is the exact Cambridge-approved 5-step procedural framework to process this data systematically. Step 1. Identify key elements. This is your asset extraction phase. Clearly pull out your A and your R. Step 2. Apply relevant principles. Make a strategic decision. Are you dealing with the nth term, the sum to n, or the sum to infinity? Step 3. Execute the analysis with clear working. This is your core algebraic manipulation. You need to state A explicitly, show the exact division equation used to find R, and physically write the formula out before substituting a single number. Step 4. Verify results. Take a step back and ask, does this answer make logical sense within the context of the initial data? Step 5. Present in the appropriate format. Applying this seamless 5-step transformation turns a scattered, low-value paragraph into a certified A-star mathematical asset. Now, we need to shift our focus to Phase 3, critical analysis skills. Let's break down the ultimate problem-solving triad: deconstruct, solve, and evaluate. This structural architecture is exactly how you maximize your return on investment during the exam. I want to run a live venture audit challenge right now. Imagine a highly complex Cambridge text case study. A company's profits follow a geometric progression. They make $50,000 in year 1, but their profits are decreasing by 10% each year. Okay, what is the highest value data point you must extract from that scenario? If your mind immediately jumps to a common ratio of 0.1, your analysis just failed the compliance scan. The profits are decreasing by 10%, which means the retained value, the actual common ratio R, is 0.9. Deconstructing the given information and extracting the precise data is Phase 1. Phase 2 is solving, breaking it down into logical steps and executing systematically. Phase 3 is evaluating, checking the reasonableness of your asset. Think about it. If you ran the solve phase and calculated that a company losing 10% of its profits every single year somehow generates an infinite amount of money, your evaluation phase should be sounding a massive boardroom alarm that your solve phase was totally flawed. And that brings us directly to evaluating evidence quality. Before we see if your response can secure a top-band valuation, I want to take a quick pause. Make sure your personal academic assets are properly managed. Subscribe to Ace the Exams right now and turn on all notifications. Whether your focus is Cambridge IGCSE, O-levels, AS, or A-levels, this channel is your weekly board seat to secure elite grades. Okay, back to the audit. Consider this structurally flawed statement a student might make. Since the common ratio is negative, the series cannot have a sum to infinity. The core liability in that pitch is the word negative. And negative common ratio does not prevent a sum to infinity. Think about an alternating series where R is, let's say, negative 0.5. That absolutely converges. The actual limitation, the actual mathematical assumption that must be rigorously checked, is whether the absolute value or the magnitude of R is less than 1. You must assess the effect of this exact limitation on your final conclusions. This level of critical evaluation, identifying precise mathematical constraints rather than relying on loose vocabulary, is the exact skill required for demonstrating top-tier evaluative reasoning and securing higher-order marks. We are now entering Phase 4, Top Examiner Warnings. For this section, I have personally extracted the top 3 vulnerabilities directly from actual Cambridge Principal Examiner reports. We're going to rapid-fire through these liabilities so you can spot and patch these flaws in your own work immediately. Vulnerability 1. Answers are too vague. When the examiner asks for the range of values for a variable x for which a specific geometric series converges, simply writing r is less than 1 is completely unacceptable. It's too vague. You must actively substitute the expression for r in terms of x and solve the specific inequality all the way down. Vulnerability 2. Forgetting to check format and presentation. This usually means writing your final answer to the wrong number of significant figures. If the syllabus explicitly demands 3 significant figures and you leave your final calculation at 5, you've just incurred a completely unnecessary penalty. You're bleeding equity for no reason. Vulnerability 3.
Answers are not specific to the context given. Let's say the question models the length of a swinging pendulum over time. If your calculated sum to infinity ends up being a negative number, and you just leave that negative number sitting there without any contextual commentary, it shows the examiner you are completely disconnected from the physical reality of the data. Pendulums don't have negative lengths.
Finally, we need to talk about your ultimate safety net. Examiner alert. Students consistently lose marks by not showing they're working. Even if your final answer is completely wrong, method marks can save your grade. I need you to treat this as your premium academic insurance policy. We call this the method mark strategy. If your final calculation is off by a tiny decimal margin because of a calculator slip, but your entire mathematical process was structurally sound, logically ordered, and beautifully documented, you still retain immense value. Cambridge operates strictly on this principle. If you clearly execute your process, writing out the correct formula, physically showing the correct substitution of A and R, you successfully secure the M marks, the method marks. A simple arithmetic error at the very end might cost you one final accuracy mark, but your meticulously documented methodology protects the bulk of your grade. It acts as a shield against total valuation collapse.
So, as we close this briefing, I leave you with this final provocative thought. Are you actually showing the systematic analysis that examiners are auditing for? As you prepare for your next exam, remember to execute the due diligence of decoding the exact constraints of the question, strictly allocate your formulas, and always conduct a final compliance check of your methodology against the marking standards. Your success relies not just on knowing the math behind geometric progressions, but on systematically and professionally proving it. To ensure you never miss an audit like this again, subscribe to Ace the Exams, enable the notification bell for our weekly board sessions, and drop a comment below stating your target grade, your qualification tier, and your subject. Class dismissed, executives.